Okay, so we are back in the third part of the video. Let me just start the slide. So this is like the we were talking about on the previous video on the facial features. So I was talking to you about the area of the face, the eccentricity, the orientation of the face, the bounding box ratio, extent, holes, and the centroid position. So all these facial features basically help us in analyzing a non-facial region to a facial region. Let us look at the next step, which is like called the region labeling. After we have analyzed all the images that were obtained from the morphological operation, we pass it through the stage, which was elimination based on primitive facial features, which was this stage where we looked at all the facial regions, all the facial features of a face, and then we analyzed like which region is going to be considered as a facial region. In region labeling, we just take that region which was identified as a facial region and we put a rectangle across it. This helps us in identifying which are the faces in the region. So you can see the red rectangle like shows which faces are detected. Since in this picture we have three faces, therefore we have three individual rectangles. For all the faces that we will have in a picture, there will be individual rectangles identifying them to be one face. Um, so this is basically the part of the region labeling, and you can see like the model works and it properly detects all the human faces in a color image. Let me go through the performance of the face detection model. So throughout my experimentation on this model, I have used like 80 particular faces and I have received a positive detection rate of 75. Now this detection rate basically tells me my model works for somewhere in between like 92 to 95%, which is a good bet because I am using a very simplified model and I'm trying to achieve a good performance out of it because I do not want the model to be too complex or require too many things. So it will be really a simple model to go look at and implement. And out of the 75 detections, we got like three false detections where it was saying it was a phase but it wasn't a phase. So that was a false detection. Therefore, the precision is going to be around 94 to 97%, which is really high considering this is a simple model we implemented and it does what it's supposed to do, and we have really high detection rate and precision rate. So I could successfully say that my model works and it detects human faces in a digital color image. And this could be used in various different applications. But before we look into like all this application and we talk about like what's the scope, let me see like what's the limitations also of this model. So the main aspect of this model is looking at the morphological operation stage because that stage helps me get rid of occlusion. But there are scopes in much more in refining that morphological operation stage so that we could improve the detection rate, we could improve getting rid of all the unnecessary components in the image, and that will help us in achieving higher detection rate and precision percentage. Secondly, the model completely depends on the skin color model that is defined in the first stage, which was the RGB, HSV, and YCBCR model. The problem with that model is like it analyzes a whole different of images. But if we had given it much more number of images and much more number of settings, then it could be like able to go and come up with a much more defined set of rules which could be used in the skin region segmentation phase. So that's the thing, is like if we have increased the number of images, for me my resources was less, so I could not go and develop much more number of images to go analyze. But if we would have been doing, and if we have designed it a little more, we could do it given the time required, then we would have a higher number of like detection rate because the model will give out a much more defined bounding rule. So these are like the few limitations what we have in the face detection model that I designed. Lastly, we'll be looking at like the conclusion. So basically, the observations we look at now. We know like there's a lot of research is going on in the field of face detection and its use in various applications. But the purpose is to make a simple yet efficient face detection system. From the slide one, from the beginning of this project, I concentrated on one thing. I'm going to make a face detection model which is simple, but it's going to be efficient. This is what we have achieved. Occlusion still continues to be a issue in the face detection model, and there could be a lot of effort done and a lot of improvement could be there in place. This is a good place to go do research work on because this is a good place where it could be done. Um, Next, like I would actually say that the project was successfully completed and it achieved a high detection rate and a high precision too. So I could finally say my physics model is simple but very efficient and provides high efficiency. Next, we just look at like the slide which has all the references. I have used like I read through all those papers, and these were the papers that were like most helpful to me for my research work on developing this model. Last but not the least, I would like to acknowledge my professor Deeping Oliver Hu for his constant guidance and his valuable suggestions, which helped me a lot in completing this project successfully. He gives us a lot of encouragement in taking up individual projects and making them go to completion. He always tries to instigate us to take up challenging projects so that we could like outperform ourselves. He always wants to get the best out of us. Thank you so much, Professor, for doing that, and thank you for making image processing and computer vision a fun subject. This is the right. So this was the end of my presentation. Thank you so much for listening. Thank you.